Good morning, everyone. My name is Khaing. Today, I will present the paper Real-Time Over-Voltage Prevention Control with Multi-Agent Community Energy Management System. Nowadays, many rooftop power are growing rapidly. This is good for clean energy, but it also creates a voltage problem because at midday, many solar panels produce a lot more electricity, and if houses do not use that power, they send extra power back to the grid. So this can cause poor voltage. And this problem is more serious for the customer who is far from the substation. So they have to reduce their solar power output, and this can cause loss of profits for the customer. This is the problem statement, and it includes three main challenges. The first one is profits and voltage control need to be challenged, and secondly, fairness are important across all customers because customers at the end of the feeder should not carry more burden, and lastly, the control must be fast because it works on real time. And for the controller decision, it had to make flexible load scheduling, and it had to choose minimum load needed to keep the voltage in the safe level. To solve this problem, the paper proposed a solution multi-agent community energy management system. And this is single community views, and this is system view. And this house has home energy management system and it's done real-time log and PV data to this same community energy management system, and then it follows the data, the signal from SEM, and it controls its home appliance according to the signal. And this is the system views, and this is the SEM. Each SEM has one community area, and it collect data from home, check whether the voltage position, and it also decide how much flexible load is needed. And this is the TSO. It receives data from this community and send voltage reference value back to this. And this is the substation for LTC. And this can help voltage support from the main distribution system. This is a real-time control logic in this paper, and the left side is the control log, local control loss, and this is system level coordination, and this we RCS logic, and it is start with from the highest voltage node, and then it activates schedulable load. After that, it checks voltage limit, and if the voltage is still not safe, it shift load and also remove unnecessary schedulable load, and then it update voltage reference, and the process is repeat this again until the system is stable. And this is TSO evaluation review. And firstly, SAM updated net load to TSO, and TSO recalculate primary node voltage, and then it updates voltage reference for all SAM units. And then the system check whether it is stable. If it is yes, it is done, and if no, the system repeat this again. This is the final mechanism used in this paper, and this shows the profit sharing ideas. The first one is a plus PV share, and the second one is flexible load share, and from this we can get fair profit. This is the equation used, and each customer profit can get from the total profit with a multiplication of these two these two surplus PV share and plus well load share. A is the weight of surplus PV share and B is the weight of plus well load share and A plus B equal to 1. In this case, for example, at noon many solar power when produce a lot of power and so this can cause poor voltage. So we need more plus well load and so the system increase the value to encourage flexibility. So customer who provides more flexibility load can get more profit. So from this mechanism, we can reduce location unfairness and so customer who provide more surplus area or more flexible load can get more profit. So it encourages PV use and voltage support. As a simulation result, this graph, the y-axis of this graph is voltage and the x-axis has two side axes and it is in the 3D time graph. So this is time slot and this is customer number. This graph shows the change of voltage according to time slot and customer number. And as you can see, without load shifting, our voltage remain visible and with the proposed method, voltage remain inside the allowance band. And as a key result, the added power curtailment drop to 0. So in this case, we can remove the curtailment. And extra power industry increased from about 9,000 kilowatt hour to 30,000 kilowatt hour. So it is about 44.5% higher. And total profit improved by about minus 100,000 yen to 39,000 yen. So it improved about 71.6 thousand yen. So as a conclusion, the main idea is to control flexible home load to prevent PV voltage in a smart way and it uses SAM, HANS and DSO together and so it can remove PV cutting and it can prevent poor voltage and it's also suitable for a large system with 1,800 customers in a time.